Hello everybody, and my name's Harry. So, today I'm going to talk to you about astronomy's most interesting branch, known as astrophysics. So, let's jump right in, shall we? So, what do astrophysicists study? Well, asteroids, black holes, nebulas, comets, neutrons, and many other bits and pieces that make up the universe. Surprisingly, all of these things can be categorized into a single category, the category of heavenly bodies. Many of these bodies are part of star evolution. Allow me to explain. In space, there are clouds of radioactive dust called nebulas. This is where it starts. So, electrons pull the dust together until it's about the size of a baseball. Then gravity takes over until it's about the size of a house. Until they become so big that all the radioactive energy starts to make them burn, making them protostars. Protostars bash into the biggest one until it descends into our next stage. Okay, at this point in time there's a fork in the road, a large star or a small star. So, we'll take the large star path because it's the path our sun took. Now, how does a large star form exactly? Well, unlike a small star, it stays in the nebula a lot longer. Entire deserts of radioactive dust are flung at the protostar until it becomes around the size of a planet. Then it descends into our next stage. Red supergiants are so massive that if our sun was about 1 millimeter wide, then a red supergiant would be about the size of a 5-foot beach ball. Now, the radioactive energy making stars burn overheats like a computer until it eventually explodes like a fuse and descends into our next stage. Okay, a supernova is basically a nuclear explosion so massive it could wipe out several galaxies in seconds, and it would take entire millenniums for those galaxies to reform from the dust. Now, how does a supernova happen? Well, as I said, red supergiants are made up of poisonous gas, and that poisonous gas, in combination with radioactive energy, keeps bursting out. This energy is purified through the vacuum of space, but all that pressure held in means that about after 4 billion years after the large star became a red supergiant, the supergiant will explode into a supernova, leading us on to the final stage. Okay, so the final stage depends on how big the red supergiant got before turning into a supernova. Now, 0.0001% of a red supergiant is so deep in that when the explosion finally happens, the explosion pushes it all together, making it so dense it either becomes a neutron star, or if the red supergiant gets big enough, a black hole. Everybody knows about black holes, so I'll cover neutron stars. Now, first thing I should tell you is neutron stars are heavy. They are much bigger than Earth, but they're heavy for another reason besides that. Now, if you weighed Earth, sure it would weigh about the weight of 1 trillion blocks of iron, about this big. But a neutron star, much heavier. Now, if you took a rock from Earth, it'd weigh about 1 to 5 kilograms. If you took a rock from a neutron star, it would weigh 20,000 to 100,000 kilograms. Same size rock, much different weight. That's heavy. Sadly, I'm running out of time, and that's the end of the chart. So, bye-bye.